That I'm a master's student at Robarts Research Institute at the University of Western Ontario. My name is Dean. My supervisor is Paula Foster, and we do imaging, so we do magnetic resonance imaging. The lab sort of encompasses a few things, but my project specifically looks at breast cancer metastasis to the brain and sort of detecting it in the early phases. It's preclinical, so it's not a human model yet. And I really want to tell you guys why we, as cancer researchers, need these. Research operates on grants, basically large amounts of money that are given to individuals or research groups to conduct the research. They're very specific. You have to have a very detailed proposal that you have to put together, submit. It gets really heavily reviewed, and then if they accept you, you get funding. If not, you have to move on to another application or revise your grant. So basically, no funding means no research. So what I want to look at is where we get some of this funding from. As a disclaimer, I'm not here to critique Canada's Economic Action Plan at all. I couldn't do that. If you've ever looked at the document, it's about 424 pages long. But I did try to go through that. I'm just trying to paint a picture of how much the government gives towards research and then cancer research. So if we look at the Canadian budget of 2010, it's about $280 billion. About 65% of that goes towards healthcare. In general, that's hospital costs, physician costs, and prescription costs. 8% goes to defense. I call the other categories about 27%, and that encompasses everything else. In terms of post-secondary research, Canada's Economic Action Plan has given $4.9 billion to post-secondary research. That is essentially what they've contributed. And if you look at that, that's about 2% of our budget. And that's to all research at universities, specific research institutions. If you look at that, where it goes into, the government has a few organizations. They have the Canadian Institute of Health Research, the National Science and Engineering Research Council, as well the Social Sciences and Humanities. But if we look at the CIHR, if you go to their website, they say what grants they've awarded if you want to apply for a grant. So if you look at their grant statistics from about 2008 to 2010, you see that they give out $1.2 billion to research in general. Now, of that, though, if you research how many of those are related to cancer, it's about $244 million. So specifically cancer is $244 million, which is about 20% of the money they give out. And if we say that about 20% of all that, then $4.9 billion that they give to post-secondary research goes to cancer funding, we get a nice little pie graph that shows about 0.3 of this $280 billion. So 0.3% goes towards cancer research. Luckily, there are other groups that give money. The Canadian Cancer Society, for example, they give these research grants. It's very, very competitive, and it's pretty much directly related to how much money the institution has to give. If you look at the Canadian Cancer Society, in 2008, they had 413 people applied for a big grant, but of that, only 81 actually succeeded. So actually got the funding they wanted. About 4 to 5 or 80% of grants they just couldn't fund because they didn't have enough money. That's a big proportion of it. And so basically the more money the Canadian Cancer Society has, the more money they can give to these grants. That's one reason why we need people, we need donations to Cancer Society. We need you guys to go raise money, sponsor your teams. So then I guess the next question to ask yourself is, why does research cost so much money? Where does all this money go? If you look at the cost, this is from my lab. I spoke with my supervisor. If you look at one project in our lab, so like potentially the project I'm doing, it's a 2-year project. Like I said, it's looking at breast cancer metastasis to the brain. If you look at how much that would sort of cost per year for our lab. So to run a lab for one project, you have a technician, maybe a lab technician and a grad student, be myself. So that would be about $60,000 a year for the stipend. I can tell you as a graduate student, most of that money goes to the technician. As well, if we look at the lab supplies, so how much supplies are going to cost, and that can really be anything from something as simple as test tubes to something as complicated as antibodies that are used for research, and they can cost about $10,000 a year. Because we're preclinical, we do some animal research. In order to purchase and house the animals, that's $5,000 a year. We go down services, and that would be maybe sending something out to get tested. We get about $6,000. Because we do magnetic resonance imaging, running the MRI, they're really expensive to buy, and running them costs anywhere from about $175 to $600 per hour. And considering my work, one of my scans, when I scan the mouse brain looking for the metastases, takes about 40 minutes. So if we want to get a lot of things scanned, it can quickly add up, and that's about $40,000. And then if we look at travel to conferences, you have to go to a conference to show your work so that people can recognize it. Companies might want to pick it up to go into the next phases, but that can be about $3,000. And then publications, and you want to publish it maybe in a journal, a medical journal or something, and once again you need to do that in order to not only get funding but get it recognized. That can cost about $1,000. So in total, that's about $125,000 a year for one project in one lab. So that is a little humbling when my supervisor sends that to me. That's the preclinical. And so that's the research. Essentially, you have to do that for a number of years before it can go into the actual clinical research. Clinical trials essentially have 4 phases. But phase 1 is where they potentially drug, or we have something we can use to try to fight cancer. What we have to do is first assess it on some healthy volunteers to make sure it doesn't cause other problems. And that is done usually with a small patient group, or healthy volunteer patient, but just to make sure it doesn't have any bad side effects that we weren't observing. Phase 2 is where you actually test on a small group of patients to see, is this doing what we want it to do? But then once you've gone on to phase 2, you go to phase 3, which essentially the same thing as phase 2, but you use a very large patient population. You want to make sure that, I'm sure you've all seen commercials where they advertise drugs and they talk about the side effects. What's called phase 4 is once they've actually approved it, it's okay to use, and in Canada, it's Health Canada that actually approves, yes, you can use this drug, then it can actually start being sold for its purpose. If you remember preclinical, that can take about 5 to 10 years to get enough, to convince enough people that we should test this in humans. So if we look at the preclinical, it was about $125,000 a year. That's specifically from my lab. Phase 1, phases 1 to 3 can take anywhere from 5 to 15 years because you have to test it in enough people. It's very hard to administer. You have to make sure there are no maybe long-term side effects. And if you look at the cost of those, if you look at phase 1, the average cost of a phase 1 clinical trial per patient is $15,000. So that's per patient. Keep in mind, phase 1 is probably done on about 20 to 100 people. Phase 2, it on average costs $19,000 per patient, and this is a slightly bigger sample group, 20 to 300. And then if you go into phase 3, and that can be about $26,000 per patient at anywhere from 300 to 3,000 patients. The important thing is that to make it to the end of phase 4, only about 1 in 1,000 drugs will make it to this far. Others will be lost along the way. Maybe they cause some damaging side effects. Maybe they're not doing what they should. But all these costs, and until they can make money, is at phase 4. So all those costs up to that point have to be somehow taken by the company. If we add all that up, it can cost anywhere from about $986. So I'll just leave it at 86, but maybe $1 million just to get a drug from the bench top to the bedside, which is, I think, an incredible amount of money, especially considering that only 1 in 1,000 will actually make it. Most agencies, such as the Canadian Cancer Society, are limited to how much money they can give to grants. Not all of them can be awarded. And if you look at especially this year, there are tough financial times in the past couple of years. Grant applications aren't dropping, but research money that people are putting aside for research and that people can raise is dropping, and so much less people are actually getting the research granted in the time. If you look at Relay for Life last year, in London alone, raised $321,000, which, if you consider that's London alone, that's enough to run my project, my lab. It's enough to run it for about 2.5 years. So that's you guys right there. That's everything you guys have raised. And I mean, if you combine that with the rest of Ontario, even the rest of Canada, it ends up making a big contribution. Thank you guys for your time, and hopefully I've convinced you why we need you guys.